Hello everyone, welcome to my tech channel Tenet Pro. Today's discussion topic is load balancer concept. This video is following by the F5 product for the example and for the comprehensive perspective, even for the concept perspective also. So this entire video will be concept driven. Yes, this whole video is driven by why, how and what. By following these three golden circle. Why, the purpose, why we need the load balance, why we require, why the load balance is needed. Then how, if it is required, then how to load balance. Then what is the result of the load balance, right? What is the benefit of the load balance and what is the outcome of the load balance. So this entire video will be driven or followed by these three golden Simon Sinek circles. Yes, let's start. First, why load balance? Why we need the load balance, right? Why we require to balance the load in between server and clients, right? I will try to explain in these sections. Yes, just imagine you have one web service that is given example abc.com. Yes, and you have make it public facing. You have published it in private internet cloud or public cloud so that everyone can access your service. Your server comes under production, right? So in this situation, yes, from entire the world and from anywhere, one client try to access your service. Yes, your server is ready with the service and he is be able to access the abc.com because you have the node, you have configured all the services for the web server. And yes, you have internet, we have make it public facing, so your user is accessing your service from internet, right? As we expected, it is happening. But thing is that challenge is that here you cannot predict as it is internet facing tomorrow or day after tomorrow how much user could come or how much user could hit your server to access your service, because as it's public facing, right? Anyone can access your services from enter the world. So just think about if any day user get increased, right, from enter the world, then everyone try to access your server at a time, right? But your server is not capable or not that much of hardware requirement to handle this much of traffic, right? So in that case, as you are not be able to predict earlier also, right, this much user could come, right? So in this situation, your server could be high CPU utilized, high memory utilized, or get high temperature, right? So in that case, your server might crash. It be out of service. It's no longer be able to services to the clients, right? So in this situation, your business will get impact, right? Your service will be get impacted for these situations, right? Now in these situations, if you are the owner of the services or websites or of the service server, if you are owner or if you are the manager, right? In these situations, you might think that yes, if I could have 3 more boxes, right? 3 more server with running the same services, I no need to face these situations, such kind of bad situations. All right. So as we have the single node, you are thinking that yes, because of the single node, I am facing this issue, right? So the next step would be your that you will procure 3 more server, right? Three more server with running the same services with 3 different IP addresses, right? So you are thinking that you have 3 more server and you make the entry in the DNS all the server IP addresses with the name of the abc.com, right? So in this situation, you have the redundancy, node redundancy. yes, you have the entry in the DNS record of the multiple entry. So now in these situations, yes, your client get more availability, right? So first client comes to your DNS and see the first record, and it will go to your first server, right? Now likewise the second user will come and see the second record, and it will hit to your second server and run the services, right? Likewise again third user or third client come to you, come to your DNS, see the DNS record, and it will check the third entry and go to your third server. Likewise all the server user comes and see the records and go to your node. But in these situations, right, in this situation, if you think that everything is working fine, now all are perfect, right? But it is not. Why it is not? Because just think, if any day your one of the server, it could be your just giving an example for the third server, it could be crash, right? In any reason it could be down, the reason could be power down, the reason could be application crash, reason could be hardware failure. So because of any reason your server might fail, but still your user request will be forwarded to that particular failure server, because your DNS doesn't have such kind of mechanism to monitor your server, whether your server up and running, right, or whether your server is running the services. It doesn't have such kind of intelligence or such kind of monitoring mechanism, right? So it won't be able to monitor your service. Even the DNS cannot track the load of your server, right? How much it is loaded, how much connection it is handling. So this much of even other reason also there. It cannot handle the SSL offloading. Other reason is also there. So that's what again you might not be able to achieve the load balancing of your all server. Whereas though we have 3 more node, yes, you have make the entry, but still it will not work somehow. So in these situations, you will think that then how to load balance, right? You might discuss with any IT consultant or IT consultant firm, or any you will do more study then how to load balance, right? So in this situation everyone will recommend you, right? Or this is the most industrial used, enterprise used product is the load balancer, right? So here, as I said, I will give mostly example of the F5 load balancer over here. So yes, so you have to place one F5 load balancer in between your server and client, which will act as a proxy in between your server and the client. It will take all the hits from your clients, and it will forward it to the servers by running multiple algorithm, multiple mechanism, multiple following by the multiple requirements that I'm going to explain you, right? So once we place the F5 load balancer over here, first thing you have to create a virtual server, right? This virtual server, again, as I said, it will act as a proxy server or intermediate server, which will take all the request from the user and will run his all other load balancing mechanism, and it will forward to the server, actual server, right? So in this situation, as whenever you try to create one virtual server in the F5 box, yes, virtual servers is the one of the terminology of the F5. Yes, so virtual server you have to create. So whenever you try to create one virtual server using F5 GUI, you will get this much of option, right? You will get this much of option to create one of the virtual server. So here multiple option is there, forwarding L2, forwarding IP, performance HTTP, stateless, DHCP. Another option is there, multiple option is there, multiple for the multiple purpose. Yes, it is very difficult to explain every type of virtual server in a single video. Yes, I know the video is always one-way communications. That's what I would request. If you have any doubt or any specific questions, please put in comment section so that I can explain and answer, or I can make a separate video on that. Yes, so here I will give you example of the virtual server, right? So here, as I said, I will create a standard virtual server, right? Once I click the standard virtual server, which is mostly used for the load balancing purpose in the mostly enterprise network or any most of the network. Yes, which is standard, I would say. Yes, so whenever you create the virtual server comes with the IP address and the services in the sense which port it will hit or which service is going to run on that particular server. So yes, the name would be there. Virtual server, you have to put one name, then you have to put the IP addresses with the services. Yes, that IP address, whatever you are putting in creation in the virtual server, you have to make an entry in the DNS so that your user come to DNS and get it resolved with your actual virtual server IP addresses with the name. Yes, so once it gets resolved, your user could come to your virtual server to access the services. So after this creation of the virtual server, yes, you have to create multiple other thing also in the F5. That is, first you have to create a node, right? This is the terminology of F5 mostly used. So F5 node is nothing but your physical appliances, right, along with the IP addresses. This is called node. So whenever you try to create one node, it will give you the option for the put your IP address and your node name, right? So it's nothing but your virtual physical server along with the IP address that is called as a node. You have to create in the your F5 box. So yes, once you create the node, after that we have to create the services also. What service going to run on that particular node, right? Here I have given the example of the HTTP 80 port, right? So this is you can take an example as a service. So yes, after the creation node, I have to create a service, and this service and the node is called as a pool member over here, right? So in pool member, you have to call the node, you have to call the services. So pool member nothing but consists with node and service. Now as I said, the pool member, it should be one of the thing member, right? So you have to create a pool, right? Pool is nothing but it consists with multiple pool member. In a pool can be a member of multiple pool member. So here I have given the example for the 3 pool member, right, which belongs with multiple node and other services. Like here all I give it the example for the HTTP. It could be run HTTPS or FTP, other any kind of services, right? So yes, this is the important factor or basic factor, I would say, to understanding the basic terminology of the F5 load balancer. Yes, it is also helpful for those people who are speech in pre-sales. Yes, for the basic stuffs, they can also this could be helpful for them also, right, for understanding this part. Yes, so here as you have created the pool member, node, services, and your virtual server will take all the heat from the client, and it will run his own algo, and it will take the decision to send the traffic to pool, and pool will take the decision which node is available, which node is on service. Based on that, it will forward the traffic. So yes, I will explain all the mechanism later on. So after that yes, as I said earlier, right, in DNS record you don't have such kind of mechanism to monitor your services, what are the services running, whether your node is up and running. Yes, so these are the facility you don't have in a DNS record. So in that case, to achieve these things, right, you have to configure the monitor in the F5. So once you try to create a monitor, you will get this much of option. Whenever you try to configure the monitor, right, this much option is you have. Yes, it is also, there is some customizable option also there, but this is the default option. Come to you, diameter, DNS, external, Firefox, FTP, all are mostly services, right? Because see, you have to monitor the services, right, whether your service is up and running. If you are monitoring only the response of this node or this IP addresses, it will not work for you. Yes, right, because your server could up and running, but thing is that your services should also up and running, then only it is treat as a then only it will treat as a running server, right? It's quite natural. Yeah. So yes, so this much option you will get to configure to monitor your services. Even there is option of ping also, right? There is option of ICMP. You can see ICMP option is also you can also run the ping so that your node is up and running or other thing also. Yes, after not only this thing you will get, you have to configure other thing also during this monitor configurations. You have to go through that part also. Yes, I will try to explain that monitoring part in later on any video. Yes, as I said, this much option you will get. Yes, as I am running the HTTP only, I will choose the HTTP, right? Here is the HTTP, you can see, right? So if I choose the HTTP, it will automatically start to monitor the services of the HTTP. It will send the probe to that particular pool member to check whether this service is up and running. If it is not get responded, then it will treat as a down, or it will be treated as a non-production services, right? So the request will not be forwarded to that particular service, and it will get a notification to your admin or your engineering team, so that they can get it rectified immediately. Yes, this monitoring mechanism is there. Yes, there is multiple things there in between. I'll explain later on. So yes, this is the basic stuff. Yes, try to remember the basics terminology which is being used in the F5 load balancer. Pool member, node. What is the node? I hope you can understand the node. What is the called node? What is the called services? What is the called pool member, right? And what is called pool? I hope it is as of now it is clear. So far it is clear. So yes, I know it is video is always one-way communications. So I would request you put your comments on the comment section, so that I can understand your query, and I can get a reply, or I can make a separate video on that particular topic. Yeah, let's go ahead. So the second topic. Yes. So here, as I said, the pool member and the node I have created. So here I will try to explain this F5 in traffic flow part, right? How the traffic is getting flow into the in between this F5 boxes, right? All the hits comes to you, come to your F5, and F5 handle the traffic to balance the load. So here try to understand my basic my interesting thing is that make a X-ray of the any component, right? So if I make a X-ray, I will get this much of option, right? Under this F5 box, I will get a basic stuff, a virtual server, pool and pool member. Yeah, your client and server is apart from this. Your client will come to your virtual server send the traffic to pool. Yes, pool will send the pool member according to the configuration, right? According to the expectation also. Yes, so here I have given one example for the client, and that is comes with the IP address AAA, so that it can be easier to understand. I have not given any example of the specific IP. And right hand side you have the server. Yes, the server IP I have given the example for the YYY. All right. So here I will try to explain. Yes, this deployment, considering the full proxy mode deployment, or many people say one-arm deployment also. So here I have given the left hand side is the client IP, right? So just think your client try to access www.google.com, right? So first what it does, it sends to DNS. From DNS it get resolved, right? Then what happen? It's create a packet. Here in this packet, yes, payload is there, but I am giving the example of the source and destinations, right? So in source, please keep the attentions. It is really helpful. It would be helpful for you guys. Yes, so source is always your AAA, right? AAA means this is your source. It is your source. So here it is source. Try to understand. This packet is the source, and your google.com, I have given the example. You can take the name of the abc.com or any name. It is being resolved in the DNS, right? In DNS, query goes to comes with the google.com and resolve the IP addresses with the xxx.com, which is the virtual IP address. So virtual server IP address is the xxx. It gets resolved and the packet came like this, right? Understandable, right? So hope it is clear this part. Source is the AAA, which is client. Destination will definitely virtual server address. Then what will do? It will send the traffic to your virtual server. Virtual server send the pool. It's run its own algo. Try to understand this part. It's run is the load balancing algo, right? Whatever you have configured, right? So you have to configure the load balancing algo. So what is load balancing algo? I try to explain you. Whenever you try configure load balancing algorithm, right? So you will get in drop down option in F5 box this much option you will get, right? So the load balancing algo could be round robin, a ratio base. It could be least connections. It could be overserved. All right. So try to understand this. Round robin, hope you know the ratio base, the least connections. Yes, I am telling you, I will try to explain a separate video for the load balancing, entire the load balancing algo. Yes, I try to touch this part. Yes, if I have configured the least connections, whichever the server having the least connection, it will send the request to least connection server member IP addresses, right? Sorry. List connections node. Try to understand list connection member. Two type of algo is there. Here it is. So any one you can configure, and ratio base, round robin, dynamic ratio, weight base. You can put the weight, like list connects sessions, whatever the session already established based on the whatever the list connection session is established on that, it will act as a primary one. It will send the request to them. Yes, so multiple option you will get based on your requirement, right? You have to send the whatever you will configure during the load balancing algo. It will act on that only, right? So yes, mostly most of the places people use list connections also used. Yes, I would say ratio base is also used. Round robin is also being used. Yes, so here I will give an example for the ratio based, right, or round robin. So once I configure, just keep in mind, just focus this part. After this algo, again I am just highlighting this part. You got a packet after resolution, right? Source is your user, your destination user, your virtual server. It goes to your virtual server, then it starts its own algo, ratio base. Then you just check the packet header, little change, right? Your destination become the YYY, because your pool take the decision which server is the least connection or ratio base. It elects the one of the server from among the pool, and it sends to that particular based on your running algo, correct? Again I am highlighting this part. Your destination is xxx, which is your virtual server. It sends to your virtual server, and then it sends a pool run its own algo and take the decision which server it will send. Then its packet destination will be changed. If the algo is elect the server YYY, it will destination change the YYY, right? So what will happen? It will send the traffic to YYY, your server. Hope it's clear. right? Now your user came to as a destination virtual server, then your virtual server received the packet and run the algo. Based on the algo, it is elect one of the available server and it sends change the destinations towards the server, and server receive the packet. Now it will send the return traffic also, right? It will send the response to your client. So what will happen now, your server will send the destination client, right? So destination is not get changed. So destination would be your client IP, that is called AAA, and the server IP address is always source is the YYY. Try to understand here, because your server is responding and the so destination was your YYY. So YYY would be return traffic, would be your source, and destination would be a triple A, right? Try to understand this part. Once you receive the packet, your client is the AAA and your source would be YYY. As you receive the server YYY, right? So it will send the traffic YYY. It will mark the packet as a source YYY. Hope it is clear. Yeah. Now what will happen? Your server will send what will happen? Your server will respond with the request. It will send to the virtual server. Now source is YYY, right? Now your virtual server, just think this part. Your source is YYY, right? Your source is YYY. Now your virtual server will change the source with his own IP XXX. Did you notice? Your request is came to source as a YYY. Now once it's your virtual server received, your F5 box will change the source IP address as his virtual IP address, right? Then it will send to your client. Got it? It will change the source to XXX, then it will send to your client. Then it will open the google.com. Got it? So your user sends the traffic to XXX, right, from the source. So as your user sends the traffic towards XXX or the destination virtual server, it's received the traffic from XXX where he has sent the actual request. So this is the basic traffic flow, right? This is the main mechanism how the traffic is getting flow from the client to server. Hope it is clear. Again, as it's a video, so it's a one-way communication. So please put your comments or let me know which part is make you confused. Yeah, so that I can clarify more. Yes. So let's go to the next part, right? So in this proxy deployment, this is the traffic flow. Now there is I'm going to explain another thing, interesting thing in the next slide. Now one problem is there, right? Hope you remember my previous slide. If it is possible, please pause it and make reverse your video. Let's see again the previous chapter and come to this problem sections, right? Because source and destination is very important in this part also. So virtual server, I have given the example earlier also, right? What is the virtual server? What is the pool member? How the traffic get flow from the source to destination. But thing is that in a real scenario, in or real network infrastructure, right? So in real network infrastructure, deployment is little different, right? You might have one core switch, you might have multiple router, you might have multiple firewall, right? Your server could be deployed in a DMZ zone, in separate zone, right? Your F5 could be placed in a one arm deployment, right? Or inline deployment. It could be so multiple reason could be there. So in real scenario, multiple devices comes in this picture. So here I will show you one problem, right? Problem is that as I show you earlier video, problem is that just imagine your source is AAA, right? Your virtual server is again XXX, and you have three node, right? Three server with the different IP addresses. Now here, just think your source, your client tried to access web server, right? What would be his DNS? So sorry, sorry. What would be his destination, right? So his destination definitely would be virtual server, right? And sorry, and your packet will generate like this, like destination would be XXX, which is your virtual server IP address. Source would be his own IP address, right? Source IP address or client IP address is AAA, and that will be marked in your packet, and that packet will send to destination, and your destination is virtual server. Now packet will go like this, and it will go to switch, it will send to your virtual server, right? Got it? Now what will do? Your virtual server receive this packet, right? Then your virtual server what it will do? It will change the destination IP, right? Just again I'm reverse. Destination is XXX is your virtual server. Once your virtual server receive this packet, it will change the destinations based on the running load balancing algo which server is available in your server pool, right? It will change the destination. Here the destination IP has been changed YYY, right? He has changed the destination IP YYY. Why? Because it's run under this F5 load balancer, and it's elect this server is available now. It having the least connection, or it can be based on the ratio base. It could be it could be other load balancing algo, right? Based on this, one server get elected that this is the available server. So it's changed the destination IP address to the YYY. YYY is been elected Y following your load balancing algo. All right. Got it, right? So now your packet, how the packet will flow? Your packet come like this, and it will reach to here by default, because your server third server is elected following your load balancing algo, right? Got it? So how the packet then flow? Then it will send to the YYY, definitely, right? Because your F5 changed the destination of the YYY. Now once your server, try to keep in mind, you can pause also. You once your server received the packet, source is again AA, source is not get changed. So your server received this packet. Now generate reply packet with the destination AAA. Got it? Again, I'm reversing again for you. So your server received the packet with the destination YYY, which is server's own IP, and source is AAA, which is client IP, which is not changed. This is the actual client IP address, right? So your server is received this packet and generate a reply packet. Definitely, as the source is YAAA, his destination will be AAA. Now, here one thing I try to explain. Just focus your mind on this part. So here your server IP gateway is YYY.1, which is mostly configured in the router or core switch in the network infrastructure. So it is expected it is configured over here, one of the VLAN or one of the physical interface IP, that is YYY.1. Alright, so what will happen? Your traffic come here as on the gateway, right? Definitely it will go to the gateway. Now once this packet reaches to your switch or router, it will get a route to reach this destination directly without going here and here, right? Got it? So your traffic, try to understand this part. This is very important part. Let me your traffic comes here. Now your traffic going like this without going to via F5, right? So in this case, what will happen? It is happening asymmetric routing, right? Because it is come to via this path, and during the reply or response, it is taking another part. Got it? So what will happen? What will happen in case of the asymmetric routing? Your packet will choose same way as I explained. It will go to your source directly without via the virtual server or F5. In that case, what will happen? Your source, your client will check the packet, right? It sends the request to virtual server, but it is receiving packet from YYY. Got it? This is very important part. This is very important part for the asymmetric routing. So your request, your user sends the request here, but he is getting reply from here. So it will discard the packet definitely. This packet will be discarded by the user or this firewall, right? Automatically it will be get discarded, because where it is sent, it is not get reply from them only. It is get reply from other source. So it's mean asymmetric routing is happening, right? So the packet will be discarded. It will not receive the packet. But whereas this diagram is followed by everywhere in every organization, right? Most of the organization it is being used. You must have the router, you must have the firewall, multiple devices could be. So asymmetric routing happening probability is high. So in that case, the solution, yes, solution is also there. Solution is there, that is called S-NAT. Secure NAT. It's not source NAT. It's a secure NAT. In F5, to overcome the asymmetric issue or a problem, the solution is the S-NAT. Now I will explain in this slide how the solution of S-NAT works, right? As you see earlier slide, that is the problem asymmetric routing is happening, right? So now here you will see the solutions, how the S-NAT is get it resolved, this problem. Yes. So you have to enable the S-NAT in the F5 box. You have to configure. So in that case, again, as I explained you earlier also, your source would be triple a as a source IP, and destination will be your virtual server IP. It will send to your F5 box or your virtual server, and it will receive the packet. Right now it will change the destination running algo, and if you notice, it will also change the source. In place of a.a.a, it will change the destination x.x.x, which is the virtual server IP address, right? So what it will do, as the destination is y, again it is being elected, or it is being followed by your load balancing algo, which server is available. It will send to that particular server. Here I have given the example for the y. Now again you might think your server will receive this packet, right? And your server will send the packet to xxx, whereas his gateway is y.1. But try to understand this part. Very important for the S-NAT part, or to avoid the asymmetric routing. So here your source is definitely this. It is quite natural, and as your virtual server change the source IP address, is change the destination IP. So your gateway is this, right? y.1. Just a bit, sorry. Yeah, so your traffic will come to here, gateway, which is y not 1, right? So as his destination is xxx, it's not destination of the AAA. It will send the traffic to here, right? As your F5 change the source, that's what his destination is towards your virtual server. So to avoid the asymmetry routing, it has been changed his source. That's what your server destination is xxx. Then packet will go to this F5 box, whereas in asymmetry routing it is not going to your F5 box, it is going directly, because it is learning the route from here only, from code switch or firewall, or it could be your router. Yeah, so once we enable the S-NAT, it will change your source in place of actual source. In place of actual source AAA, as the source is changed xxx, then its destination become the xxx. Then the traffic will go to here only, right? Got it? Yeah. So just as expected, your packet will go to your F5 box as its destination has been changed, right? So it will receive the packet, right? Then it will generate the packet, and it will change. Just pause, or I'm also reversing. It has received the packet with the destination xxx and source is y. Once it is received, what I will do, after received, it will generate a reply packet. Source would be xxx and destination is the YAAA, right? Now it will send the packet directly to the user, and user will see he has sent the traffic to xxx, and he also getting a reply from xxx. That's what it is accepted in firewall as well, in user as well. So this is how you can avoid, or you can solve the problem of asymmetric routing situations, right? It's all about your server gateway, right? If your gateway is different node or different appliances where it is getting other route to reach the destinations, then only it's happen, right? So S-NAT is the solutions. If such kind of situations, you need to configure the S-NAT. Hope it is clear. If it is not, please reach to me, put me a comment on the sections so that I can read your query and understand your query and get back to you, or I can make a separate video for that part also. Yeah. So next go ahead to the next slide. Now here I have given one example. You might have multiple questions during my pool member explanations, right? Here I will try to explain the actual or real environment deployment, right? So here in F5 you can create multiple virtual server with the multiple services, right? Here I have given you for the 9 virtual server, right, with multiple services. So here you can create multiple virtual server with multiple services. Here I have given the multiple ports, right? HTTP, HTTPS, HTTP 443, this kind of port I have binded with the virtual server. Now yes, you might have question earlier also that can we make multiple services in a single pool? Yes, you can configure. So here I have given one example. Your virtual server is 80, virtual server 1 is 80 and virtual server 2 is the 443, and that is called your virtual server 1 called to pool. Try to understand pool 7. This is pool 7. In pool 7 I have given the name of pool 7. Pool 7 having multiple services, right? Got it? Now this is pool. Now where is the pool member, right? So try to understand this part. Here you have created multiple pool, right? I have given an example of the pool 7 because here multiple services I have called, right? Multiple pool member I have called rather. So pool 7 has called multiple pool member. So pool member, as I explained earlier, could be node and the services. So I have, where is the pool member, you might think. So pool member, I have just tried to draw this part. This is your pool member, yeah, one of the pool member. You can say this is pool member 1, right? Another one is, just think this thing. Here you have another pool member, right? So here is pool member 2, right? So your pool can be consist with multiple pool member. One pool member can be one of the services, right? So 80 is the one of the pool member, that is PM1. I have given the example, and 443, that is another pool member, which is the member of a single pool. In a single pool I can call multiple pool member. Try to understand this part. This part is little complex initially, but it is really easy. So yes, pool member and pool. So your pool can call multiple pool member. Here I have given the example with the service of pool member 80, 443 and 8445, right? So pool member is nothing but there is, you can say, let me, please bear with me. I'm little poor in, right, and this is your another pool member. Got it? So here pool member 1 red, pool member, I'm just giving the example of the color, right? Red, green and yellow, right? So this pool 7, try to understand this pool 7 binded with multiple pool member, and the pool member just called with the one service and two node. Here we are I have given here a example with the two node only. It could be multiple node, 5 node, 6 node, 8 node, 1000 node, it could be anything. So here I have given the example of the 2 node only. 2 node plus service is the red pool. 2 node plus service 443 is the green pool member. 2 node plus service 8445 is called yellow pool member, and all these red, green and yellow pool member binded in a single pool, that is called pool 7, and this pool 7 called in this virtual server, in this virtual server also, even for this virtual server also. Got it? Try to understand this part. Pause and reverse. So here you have created one pool name you put it pool name 7, and you have called multiple pool member which consists with service plus 2 node. I have given the example of the red, green, yellow, right? Red, green, yellow is nothing but pool member, and pool member binded in a pool, and that pool called in a virtual server, this virtual server, right? Hope it is clear. If it is not, please reverse, pause and listen again. Otherwise you can also put one comment so that I can clarify separately. Yes, now here I try to explain once more again. Just imagine your this is the client 1. Client 1 try to access HTTP service. How the flow will be? It will come here via the internet and it will hit to your virtual server where the service is configured. Virtual server, yes, IP also will be there. Just example, I give x dot x dot x dot x. All right, this user try to access the HTTP service with this virtual server. It will go to here. Now it will run the algo and it will send to the pool. Try to understand this pool 7, and this pool 7 run the algorithm which node is available, right? It will hit to the HTTP and it will send either this node based on the availability or this node based on the availability. At the same time, if client 2 try to access HTTPS, again here could be IP y dot y dot y dot y, your virtual server 2 IP address. It will come to here. It will see the 443, and this virtual server will call pool 7, right? Here it is the diagram. Pool 7. In pool 7, take the decisions which port it is comes with and which server is available. Then it will send either this server or this server. Got it? I might be a little lower. Please bear with me. Excuse me. Yes. So this is how. And another thing is that the inter virtual server comes with the IP address. I have given a few example, and that will be binded with the virtual server name, and you can make entry in the DNS. It should be entry in the DNS so that user can get resolute from here, right? It should be entry like service1.com, www.service1.com 80 IP address, virtual server IP address is this, and the virtual server name also. Virtual server entry is not needed in the DNS server, but I have given one table for the better understanding only. Just focus this part. Yes, in DNS must be record is there. Yes, your virtual server entry always should not be in DNS. It could be NATed IP address also, firewall IP address, other IP address also. So here I have given the directly example. So this is how the flow basic is. It is getting flow. So You can also take a snap of this chart so that you can understand how the flow it is. Here I have given example of I have created 9 virtual server for the different services, and which is called to the different pool. And in pool 7 I have called multiple pool member over here, right? Pool member is not mentioned over here, but as I show you with the red, yellow and green, right? So this is how I try to explain. Yes, this is the basic thing in the F5 load balancer configuration part. This is how it is get flow, all about concept, as I said. Hope it is clear, this slide. Yes, I'll definitely try to answer your questions following the comments or your query. Yeah, going to the next slide. Now here I'll try to explain one thing, that is inner part or device deep drive architecture part, right? Physical or internal architecture part. So mostly we deploy in HA mode mostly, right? So here I have given example of the two F5 load balancer, F5.1 and F5.2. Yes, and that management port is connected to the management switch. Yes, most of the standard enterprise network you have OOB, like out of band management network, right? Or it could be a different management switch where your management port get connected and through which you can manage your F5 load balancer. So this is the management port get occupied to connect your management switch. It is not necessary to manage through out of band management. You can also manage in band also. Yeah. So here mostly, as I said, you might have core switch, you might have DMZ switch, right, where your load balancer could be connected with this. Yes, and here I try to explain. Yes, you might require one separate HL link, or you also can run HL link via core switch also, if your data center is located physically in different locations, right? In that case, you have to travel. You can establish a separate link for the HA, or you can use common link for the HA also. That is a separate chapter altogether. It might create confusions, so don't focus on that part right away. Just focus the physical internal architecture of the F5. Here now, one thing I would like to highlight you guys, that is the one of the most commonly used terminology, that is the partition. Try to understand this part. Partition is nothing but it's a context, right? Whoever work in the ASA or other contextual devices, that is nothing but a context. Or you can compare with the VDC, right? Or you can compare with the instances, right? You can correlate. You can relate with this thing actually, but it is called here is partition, or you can hardware partition or hard drive partition kind of thing. You can also imagine. So here, as per your requirement, you can make separate partition for your separate requirement, right? Here I have given an example for 3 partitions, right? Here I have created separate 3 partition, that is common, which is comes with the by default. Yes, and another one is the corporate, another one the guest. So corporate partition always take care of the corporate traffic. Guest partition will all the configuration will be done in the guest part, and common is the by default. Hope you understand. So these are the partition, nothing but logical separations, logical partitions, right? In PC you can imagine ABC drive, you can ASA you can imagine with the context, you can FTD, Cisco FTD you can imagine with the instances, right? In Nexus you can compare with the VDC. Yeah. So here I have created the 2 new partition, that is corporate or guest. Yes, you can configure entire thing in the common partition, that is different thing. But yes, you can also configure separate partition for the separate requirement. Got it? Hope it is clear. Now here mostly we create a VLAN, right? One thing I like to highlight over here, in F5 na, you can heard that is the self IP. Self IP is nothing but IP address you are putting in the interface. That is called the self IP. Whichever the it could be physical interface, it could be the logical interface. But yes, mostly we use the logical interfaces IP address as a self IP, right? Self IP is nothing but you can relate with the interface IP. Yeah. So VLAN 10 I have created in the common partitions. VLAN 99 and 100 I have created corporate. Yes, VLAN 150 and 250 I have created and the guest partition. Yes, why you might think that why we are creating two separate VLAN in the corporate section and guest section, because we have to consider the internal and external also, right? Internal is the your server or node will be located, and external your heat will come to your virtual server, right? So it should be two different zone, internal or external. I'll explain it on more, right? So here common partition is by default partition. Here I have used for the HA link purpose for this thing. So corporate is the two more interfaces, that is VLAN interfaces. Guest also I have created two different interfaces, that is the inside, outside, or internal, external. Yes, there is another concept that is called route domain, right? Route domain is nothing but you can correlate or compare with the VRF, right? In VRF sections, VRF concept you can compare with the route domain. Your route domain 1 and 2 you can configure. Here I have given the example for the route domain 1, which will handle your corporate traffic, right? And route domain 2 you can configure for the guest traffic, whichever the traffic will L3 traffic or traffic will flow over that particular route domain. It's just a logical VRF, you can say. You can configure, you also avoid this part also, but as per your requirement, in large deployment or huge deployment, it is required, very much required, right? That's what I try to explain this part also over here. So route domain is needed, right? Yes, I hope it is understandable. The partition part, yes, partition you have created. Common partition is common. From common partition you have created separate other partition also. Yes, route domain, or you can call, I'm just try to correlate with other terminology, but don't relate and don't be confused. Yes, it's a kind of VRF. So second thing is that the physical connectivity, I hope it is understandable. That two link I have binded with the trunk port channel, and that I have configured with the trunk, right? So that my entire all VLAN can be get passed, and I have mapped the interfaces also. So this is the inner part or internal architecture, or external physical architecture, you can also say. Yes, multiple confusion, multiple doubt, multiple query could be raised. Yes, as it's a video, so I would request please put in comment section so that I can explain it more, or I can explain it one-to-one also. Yeah, so go to the next slide. Here I try to I hope it is clear. Here I try to explain the more internal part, right? As I said, VLAN 99 and 100 I have created for the corporate traffic, right? Corporate, why I created two VLAN in the same partitions, because one is the internal, one is the external, right? So let me explain over here again. Yeah, so this part is external, right? Sorry, I'm really sorry, excuse me, just a minute. This is internal, right? And this is external. This is the boundary, logical boundary, you can say. Yeah. Here in your internal zone, your server is located, right? VLAN 100 is responsible to connect your server, right? So in this VLAN member, in this network, try to understand, try to take a snap of this page and try to understand later on also. You can also pause or reverse. So here VLAN 100 is connected to your internal zone, where in this VLAN 100 I have given example, right hand side another F5 box. You can forget about the right hand side F5 box. You can also try to understand with the single F5 box also, left hand side. So here, as it is HA, that's what I have to understand other part also. That's what I draw two thing also, two F5 box. This is F5.1, I could say this is F5.2, right? F5.1, F5.2, load balancer 1, load balancer 2. My drawing is little horrible, yeah. So your VLAN 100 is the part of your internal zone. Try to understand a very important part. So this is the connectivity, right? Here in this connectivity, or you can say it's a network. So here you can say, as I told you earlier, self IP. In F5 we called as a self IP. Self IP nothing but interface IP addresses is called as self IP address. So I have put the IP address of this VLAN, that is 134, right? And here in this VLAN, this two server is connected, abc.com. Under the abc.com we call two node. Try to understand. And these two node in internal zone, they're connected with the VLAN 100, right? As there is a two box. Now try to understand this part. Here is self IP and this is the self floating IP address. So what is floating IP address? One virtual or VIP IP you can correlate, but it is called in F5 that is the floating IP, which float in within the box, right? So you can correlate with the HRP virtual IP, VRRP virtual IP, or other virtual IP. You can compare it, but it is called self floating IP in F5 box. So try to understand as it's done in the HM mode, right? It is in HM mode. That's what I give the example two boxes. Yeah. So here your node IP is 37, 36, right? But try to understand your gateway, server gateway is the virtual IP address. So virtual in the sense your self floating IP address, so that whichever physical box is available, it will send to that particular boxes. Like just think this box left hand side box is up and running and it is primary, configured as primary. It will send first, it will come to this floating IP and it will send here, right? From here it will comes under this group, and now external VLAN 99 it will communicate with here only, right? It will create a float IP over here. So you have to create virtual server, as I explained earlier. Hope it is clear to everyone, right? So this is the virtual server, and this virtual server is connected to your external. So you just imagine, I'm drawing, try to explain more little bit over here. So this is your user will hit your virtual server, right, via internet, INT, right? Via internet it hits to virtual server, and based on the other algo what I explained earlier, selected algorithm, it will send to your available server. So it will go like this. So this corporate partitions, your corporate server is abc.com, right? For the guest, this is very important part. For the guest, sorry, please excuse me. Oh, black. So yes, so for the guest you have the server XYZ, which it or the client comes to here, right, via again internet. Yes, I have I'm explaining repeatedly internet, but it could be your internal also, right? Mostly people use internal server access also. If it is your entire globe network, your private network, in that case your request comes from the internal network also. Yeah, so for the guest, it will hit to your this guest virtual server, which is belongs to your guest, right, guest partition. It will hit to here, then it will go to your server IP to access XYZ, right? So just imagine ABC is for your guest, for the corporate users, and XYZ is for your guest network. Got it? So this is how I try to explain, but thing is that all self IP, floating IP, and internal external zone is like this, very similar. In common partition, I have explained the VLAN 10 for the HA purpose, right? HA link, and there must be hardware synchronization must be happen, right? That's what a separate link, separate VLAN I have configured, or I have explained over here. All right, got it? Hope it is clear, right? Still I think multiple doubt could arise. Yeah, so that please reach me or put your comments on comment section so that I can understand your so that I can understand your questions and explain you more better way, right? Yeah, so this is how it is. So as of now we explain the basic partition part, architecture part, flow part, right? Now another thing is that I will explain. This is one of the major portion of the SSL, how F5 deal with the SSL traffic. All right, this is also important. So how F5 deals with the SSL traffic? He deals with this much way: SSL offload, SSL bridging, SSL pass through, no SSL or plain text, it will not encapsulate or discapsulate, and the server side encryptions. So this 5 type of SSL kind of mechanism, F5 deal with the SSL traffic. Yes, so I will explain the first 3 part SSL. What is the SSL offload, SSL bridging, and the SSL pass through. All right. So here I try to explain. Hope it is self-explanatory that it is how it is. What is the SSL offloading and SSL bridging, SSL pass through, and no SSL, no SSL, no encapsulations, no encryptions. Yeah. So this 5 kind of SSL file handle with the F5. So here I will explain the SSL upload. What is the SSL upload? What is the SSL bridging? What is the SSL pass through? Before that, what is SSL and why it is required? I will explain. So I am trying to explain with the problem first, right? So in problem, what is the problem, right? Then only the SSL comes in picture, right? So the problem with the HTTP communication is that you just imagine you have a server, right, and you have users or you have a client. You try to access the HTTP traffic. How it is get flow? It's get flow with the open clear text traffic, right? It always sends in clear text or open. The HTTP, there is no encapsulation. So the problem is that in between your server and client, anyone come as a hacker. I have given the example of as a hacker. Anyone come and access your entire data in man in the middle attack. By the man in the middle attack, as your traffic are end-to-end de-encapsulated, there is no encapsulations in purely clear text, right? So any day any hacker or intermediate intrusion can happen, and he can steal your entire data, end-to-end data, right? So this is the problem with the HTTP traffic, right? So now what is the solution then what is the solution is the HTTPS, right? So what is the HTTPS? So how it is resolved this problem, right? So in HTTP traffic, first how the communication happen, but user try to communicate one HTTPS server, and he ask, hey website, identify yourself, right? So who you are, basically this request goes to that particular server, right? Then server reply, here is my certificate to prove my ID. So prove my ID, he tried to prove himself with his certificate, right? He having the authorized certificate from the root C. So once he show this certificate, it sends the certificate to the user. Read the entire certificate and they encapsulate private key, public key, other thing, all the reading, if it is valid, right? It is a valid certificate, it is received from authenticated server, then it's established a SSL encrypted file, because SSL in the secure socket layer, it is based on the certificate, as it's received the client the authenticated certificate. Then using the certificate, it is established a secure encrypted you can say tunnel also, yeah, because this end-to-end data whatever transfer from here to there, it's all are encrypted. You can see whatever the data travel from this tunnel or are encrypted, or packets are in encrypted form, you can see, right? So how it is encrypted? Because it is used the SSL certificate to encapsulate the traffic or encrypt the traffic to send it to server. The intercommunication happen with the SSL encrypted form. So in this case, excuse me, let me erase. Yeah. So in these situations, as your data, right, travel from your server to client or are encrypted from. So in this situation, if your hacker comes and try to access the data, it won't be able to, because it is encrypted, right? It is encrypted form, all the inter traffic gets travel. So the solution is this with the SSL traffic. Yes, the SSL certificate should be valid, right? Let me show you one thing, that is, yeah, for the certificate, as I told you, right, as I told you, that is, if you see the certificate part here, I just open a google.com, right? Here you can see connection, right? Connection secure. So what certificate is valid over here sitting. So what is the certificate, right? Here you can see the detail, certificate of the detail. So what is the certificate, from where it is received, what are the content in the certificate? Signature is the SA 256 encryptions, right? Not valid before this thing, and not valid after. So this is the validation period. This is the validation period mentioned in the certificate. So it is giving by the Google to me, right? I'm the user. So here is the algorithm, public, as I said, a public key, a private key, all will be mentioned over here. All right, how much bit it is, signature, which signature it is being used. All right. So now, sorry, just a minute. The common name, the CN name is like the google.com, right? So who is the organizer here? The Google Trust Service LC, he has his own certificate, CA certificate, right? Common CA, the version, what is the version? These are the content of the certificate. Every certificate is containing this kind of information. or I can give you the example of the DG certificate server connection. Go there, see certificate, trust, detail, right? So you can also see this much of information of the certificate, right? DG cert, so organization name you need, from where you are getting, country, which country it is, which is the signature algorithm, this much information you can get. All right, so this is the example of this thing, certificate. You can see, you can check from your end also. Yeah, so hope it is clear, right? Now another thing is that so as it is the solution is the HTTPS, and it is use the certificate, encapsulate, de-encapsulate, then it makes the secure, right? So this is the basic HTTP and HTTP communications, and why the certificate, SSL certificate require, as I am going to explain the SSL upload, right? So what is the SSL upload, right? Again here this the intercommunication happen, how the communication is happening. Again your user says again in this situation a file comes between your server and the client, right? So your server comes, yeah, your server asks, hey, website identify yourself. It is asking to your F5, right? Then your one thing I just want to highlight over here, and the thing is that in the SSL upload you have to configure the client certificate only in F5 portion. This portion you need to configure only SSL profile in SSL uploading configurations, right? So then it sends then it's asked, this is my ID, I have the certificate, because he has a certificate, right? Already I have I show you, right? This is the configuration, SSL client certificate configuration you did. So based on this he show the certificate, right? He has a certificate, so he send the certificate. This is how it is playing as a server. So here the server receive the packet and establish a tunnel, right? Tunnel in the sense in the packet is encapsulated, that's what I am calling it tunnel. So all the traffic it is getting flow with the encrypted form, and this whole entire encapsulation and de-encapsulation taken care by your F5 box. Now here why this SSL offloading is needed, right? But thing is that why it is required. SSL uploading or SSL encapsulation, de-encapsulations, multiple algorithm, the high-end algorithm runs for that, right? For that you need a specific hardware requirement, right? It must be capable to handle this much of SSL encapsulation, de-encapsulation, run the algorithm, read the private key, public key, lots of mechanism happen over to establish the SSL communication, right? So for that you need a high-end server, right? So your server might not be handle this much of encapsulation, de-encapsulation things stuffs. So if you have low-end server, right, so you, in that case, you can give the responsibility to F5 box, take care this encapsulation, de-encapsulation part. Let's offload the SSL stuff to you, and you take care. My server will be responsible for the services only. So in that case it is required, yes. So yes, but try to understand this part from client to F5. Yes, F5 is play as a in between role between your client and server. So it will encapsulate the traffic. All traffic will be encapsulated between your client to F5, but F5 to server will be a clear text form, right? All will be in open form, because it is in secure zone, it is in your zone, right? And your server is not that much capable to handle all the SSL stops on run the all the algorithm. So yes, this portion, outer end, I would say outer end, all the traffic will be encapsulated, and inner end, your F5 to which is in your premises, right, will be unencrypted, you can say. Yes, in that situations your server to your F5 to client will be port 3 and encrypted form, And yes, decrypted form would be your server to F5, because your F5 is taking care of the role for the encapsulation and de-encapsulations, all the algorithm run by the F5, because F5 is that much capable and it's designed for that service also, right? For that you need the procure the license only. Yeah. So in these situations, yeah, try to understand the loopholes and other thing also. In this situation, your hacker, if it comes to in between your F5 to users or your client, he won't be able to hack, right? Because it is encrypted form. But thing is that here another challenge is that I will come to that point later on. But this is the SSL offload. Try to understand your SSL encapsulation, de-encapsulations, all running the all algorithm will take care by your F5, will not be take care by your server, because this F5 is designed for that. It can handle this much of traffic, it can run all the algorithm, and this portion need to secure only, but rest of a portion is rest of a communication path is your internal zone, right? So that's what if you have the low end server, yes, if your server is not capable to handle SSL traffic, in that case you do configure this thing, right? Next, yes, but challenge is that here if you don't trust, right, if you don't trust your internal user, in that case it is problem. In that case you have to go to other solution. So SSL, that is called SSL bridging, right? Again, SSL in SSL bridging, right, you need to configure this part two part, SSL server as well as client also, because it will act as a client as well as server, in the sense it will communicate with your server as a client using the certificate, right? So it will play as a between role between your client and server. Again, the same mechanism will happen. Your F5 will encapsulate de-encapsulate the packet, establish a secure communications with your client. Even your server will also encapsulate, de-encapsulate, and establish a secure connection between your F5 to your your server, right? So now end-to-end communication is your end-to-end communication is encapsulated form, right? It will be all end-to-end is encapsulated, but earlier one server to F5 was not encapsulated. It is insecure, you can also say. In that case, SSL bridging is needed. Here we'll configure the SSL bridging, right? In this case, if a hacker comes in this picture, you won't be able to hack anything, right? Because end-to-end is encapsulated, because your F5 is playing as a role client for the clients, and your F5 also playing as a server for the servers as a SSL encapsulations. So end-to-end, so in this case your server is enough capable to handle the encapsulation, de-encapsulation, and run the all algorithm, right? So this is you can say SSL bridging, right? End-to-end bridging. But here your F5 also taking the role of encapsulation, de-encapsulation, all the stuffs. Read the private key, public key, run all the algorithm. But earlier one SSL offloading, that is not there. Your F5 to server communication was unencrypted form, yes, because your server was not capable to handle that much load. Yeah. So SSL bridging is the your F5 will play as a SSL bridge role. Yeah. Another one is the SSL pass-through, right? SSL pass-through is nothing but it will you no need to configure any SSL server or client in your F5 box, right? In the virtual server option. So in that case, yes, what will happen? It will pass all the SSL traffic to your server directly, right? Your server will be responsible to in server client encapsulation, de-encapsulation traffic, but here your F5 will play as a pass-through only, right? But thing is that all the traffic will be encapsulated from end to end. But yes, your server should be capable to enter encapsulation and de-encapsulation, right? So these three are for three different requirement as per the requirement, but concept is the same, right? Hope you understand. In a single video to explain everything, it is really difficult. It will be go very long. Yes, if requirement is there, demand is there, I will make separate video for the separate task or separate requirement. Yeah. So these three part I have explained: SSL uploading, SSL pass-through, and SSL bridging, which is mostly used, right? Yeah. So coming to the next slide, yeah, I tried to explain over here for the HA perspective, right? How mostly HA is happen in F5 box. So here in F5 now you have to configure the devices, right? You have to add the devices, your F5 box. In devices you have to add the individual boxes, then you have to configure the device group. In device group it could be 2 or 3 multiple devices come into. So device group consists with the multiple devices. Here I have given the example of the 2 devices only, right? So now yes, top of the devices definitely partition is there, right? And top of the partition traffic group you need to create, and that traffic group or top of the partition you need to configure the traffic group would responsible to flow the traffic. Yes, traffic group 1 and 2 you have to configure active standby. This is the active standby mode deployment I have explained over here. In F5 1 in box 1 I have explained the traffic group 1 and 2 will be active. Your client, try to understand, your client coming from top will always hit to the active traffic group which the user belongs to the traffic group 1, and the user belongs to the traffic group 2 will hit to the primary active boxes, right? And if the box 1 gets down, it will hit to your traffic group 2. Then the standby automatically become the active once the box 1 get failed. So this is the mostly active standby failover scenario being used in the F5. Yes. Another thing is that I would like to highlight, that is the floating. Yes, floating IPs or the float. This traffic group and 1 and 2 will definitely float to within the devices. Once one primary goes down, it will be active instantly in the secondary. Yes, this is the active standby HA descriptions or explanations. I would say it's a very basic stuffs. Now this is the active situation, right? So in active situation, what we'll do, we can configure one boxes, 2 traffic group. One traffic group will be active in primary box, and second traffic group will be active in the secondary box, right? Your client belongs to traffic group 1, always hit to F5 box 1, and your traffic group, your user belongs to traffic group 2, always hit to the F5 box 2. So in this case, your both the boxes will be active, and both the clients will send their traffic to different boxes, as their traffic group is active in 2 different boxes. So this is how we can also, one of the way to make the traffic group active standby and active in HA perspective. Yes. Now last point is that what we load balance, right? So what is load balance in the sense, what is the benefit, or you can say, right? What is the outcome of the load balance? In that case, I try to explain the benefits, right? These are the benefits you can achieve for the F5 load balancing, right? So in security perspective, yes, you can protect your application from emerging threats. Yes, in F5 there is a WAF services also, through which you can protect your application. Authenticate user, yes, that is also one of the feature of the load balance. Multiple load balance have this kind of feature. Protect against DDoS attacks. Yes, firewall facility is there. It's capable device to protect your DDoS attack. It is also help you to meet the PCI compliance, right? You know already that what is the PCI compliance and why it is required. So it is also self-capable to be self-compliance the PCI. Simplify the yeah. Another thing is that performance. Yes, as in performance you can achieve the SSL upload, as I am going to tell you earlier, explaining you earlier. SSL upload can be achieved, traffic comparison achieve, traffic caching. Yes, traffic caching, as I said in a single video, explain everything is difficult. HTTP2 support, it is also capable. It's enhanced the performance, right? So security perspective, performance perspective, these are the benefit. Yes, resilience, for the resilience and scalability you can also achieve this much benefit, right, with this F5 box. Yeah, very short time to explain every benefits or every feature of a F5 box. Different OEM have different beauty of the load balancing mechanism, right? So yes, this is the basic overlook of the benefit of load balancer or outcome of the load balancer. Here I try to explain one thing, that is this is the resource provisioning feature window of F5. Here I will take a little time to you team. These are the different services, or you can say it's a module, different kind of module, right? Already you are aware module can be applied to other devices. All the feature or services comes like a modules, like or blade. In checkpoint you can say blade, here you can say module, right? So yes, here multiple services there, like I try to explain few of them. This is the LTM, whatever today I explain in this video, that is focused purely on LTM, which is local traffic management, and application security. As I say, other fire security policy you can achieve through this. Yes, fraud protections feature is also there. Yes, LTM, as I said, LTM mostly used for the local traffic management, and GTM mostly used for the DNS load balancing, right? It's a different service, different configuration, different you can say different concept also. And this is the another service is the link control, right? Link control is link controller is nothing but a link load balancer. Just imagine you are load balancing the application, right? Here link controller, you can load balance with the two different link. It could be internet connections, it could be MPLS connection. Just imagine you have 200 Mbps 100 Mbps two line, but you want to use both of them. So you want to utilize both of them 200 Mbps, right? So in that case you need to load balance them, right? So in that case this feature is needed, link controller. Yes, AVR is there. Policy enforcement is it's separate chapter altogether. Application is this is the application related firewall, you can say also. Yes, iRule is a different segment, or segment in the sense a different feature, you can say, that I will try to explain in separate video. iRule is the very beautiful feature of the F5 load balancer that I will try to explain or in separate video. Yes, so these are the different features. Just to enable this you need to procure licenses, right? And you need to provision which mode you want to. You have to check nominal and other models also there, small, nominal, you can say. So yes, you need to procure the license or activate this feature as per your requirement, so that you can use multiple blades and multiple feature in a single box, right? So this is another very beautiful module feature in the F5 box. Hope it is clear. Yes, based on demand I will try to hit each and every feature. Please bear with me just a minute. Yeah, so yes, this much I can say regarding the F5 load balancer. Yes, this is very basic stuffs through which you can understand the basic concept of the F5 load balancer and why you require the load balancers. Hope it is informative to you. Hope it is helpful for you. Hope your time is not waste. You can understand a few of part of the F5 load balancer. Yes, again I would say, as it's a video one-way communications, I won't be able to get your questions, won't be able to answer your doubts, mitigate your doubts. So I would request please put in comment section so that I can answer you. Yeah, thanks for your time. Thank you very much. If it is informative to you, please forward to your colleagues, to your friends, so that I can also get a little advantage of that, a little take a leverage of this basic tutorial stuffs, or it can motivate myself also. Yeah, thanks for your time.